Okay, in this video we're going to talk about probability. So probability is the likelihood of something happening. Theoretical probability is what should happen based on sets. So remember, if you think of a theory, it's something that hasn't possibly been tested yet, so you think it's what should happen. Experimental, it's what actually happens. So if you did the experiment, this is what actually happens. A sample space is a set of all of our possible outcomes that we could have. Okay, so list the sample space, so all of our possible outcomes that we could have. So flipping a coin twice, so a coin has heads and tails, or it could have got tails and heads. Rolling a dice, I could have gotten 1, 2, 3, 4, 5, or 6. So that is my sample space. It's all of our possible outcomes that we should get. Okay, we could have also gotten heads, heads, or tails, tails. Okay, so theoretical probability is the probability, the amount of possible outcomes over your total possible outcomes. So what I say, it's basically what you choose over your total. Okay, and the way we say it is if I have like this symbol here, it means the probability of 4, the probability of rolling a 4, or probability of pulling a 4 from a deck of cards. Okay, so it's what you choose or your success over your total. Okay, in a lot of these situations, you're going to see the word or. Okay, if it's the word or, we're going to be adding our probabilities together. Okay, and we're going to be multiplying. If you see the or, it's going to be adding. Okay, so just some things to remember. Dice always have 6 sides unless we tell you it's different, but in this situation, they will always be 6-sided. A deck of cards will be 52. We have 4 suits, hearts, diamonds, spades, and clubs, which means there are 13 of each if I have 4 suits. Okay. The red ones are hearts and diamonds, the black ones are spades and clubs, and then 4 of each of one of the suits. So I start off with ace, and then I go 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. These do not count as 11, 12s, and 13s. And then just remember there are 4 of each of those because of the heart, diamond, spade, and club. Okay, so you roll a 6-sided die, find the probability. So if I'm rolling a 2, okay, there is 1, 2 on a dice, but I have 6 options. Okay, if I'm trying to roll a 7, well, if it's a 6-sided die, there's no possible way to roll a 7 because there's only 6 sides. An even number, I've got 2, 4, and 6, so I add them together, so I've got 3 total, or 3 that I can pick from, and a 6 total, so we always simplify our fractions then. So that would simplify to 1/2. Okay, if we look at a deck of cards, aces. There are 4 aces in a deck of 52. Okay, and then we simplify them so they're both divisible by 4, so I'm going to get 1/13. Probability of an ace or spades. There are 13 of each suit. Okay, so I add them together. Oh, an ace of spades. I apologize. An ace of spades. There is only 1 ace of spades out of my 52 cards. A king or an ace. So there are 4 kings and 4 aces, so I have a total of 8 to choose from. Okay, there's my or, which means I'm adding out of my 52, and then we simplify. All right, so the next one is if we roll 2 dice. So if I'm rolling 2 dice, I'm going to have 36 options because this is me rolling 2 die. Okay, so anytime you see the words 2 dice, that means you have 36 possibilities. Okay, so it says the first one, the sum is 5. So I'm going to go through and I'm going to look of all the ones that the sum is 5. Okay, so there are 4 that I can pick from out of my 36 total options, which would simplify to 1/9. Okay, my next one is rolling 2 4s. So I'm going to go through. There's 1 option to roll 2 4s that I can pick from of my 36. Okay, the next things we're going to talk about is two different types of events, independent events and dependent events. Independent events is the occurrence of one event does not affect how the second event can occur. So if you roll a dice and then pick a card, me rolling a dice has no effect on me picking a card because it's not the same thing. They're independent of each other. Okay, we're dependent, they depend on each other. My first thing can affect the second thing that I do. So if I pick a card from a deck, and then I kept it, that affects me not being able to pick it the second time around. They're dependent on each other. Okay, and these ones we're going to multiply these answers. So you're going to see this word and in here. Anytime you see an and, you're going to multiply those probabilities. Okay, so flipping a coin and then rolling a cube, they will not affect each other, so they are independent of each other. Choosing a marble from our bag, keeping it, and then choosing another marble. That's going to affect the outcome of the next one. So they are dependent on each other. What is the probability of rolling a 6 on a cube and flipping a coin and getting tails? Okay, so if I do the probability of rolling a 6, I have one option of my 6. And then it says of flipping a coin and getting tails. Well, I know that there's one option out of my 2. So we multiply it and get 1/12. Okay, what is the probability of drawing a queen? Well, I know there are 4 queens of my 52. Okay, we return the card and then draw a king. There are 4 kings. I return the card, so I'm still at 52. And I have 4 kings to still pick from. Okay, so when we multiply those and simplify our fraction, we get 4 over 663. Just make sure you simplify that fraction. Okay, this top one, if I'm rolling a cube and then flipping a coin, they're going to be independent. Okay, if I am drawing a queen and I return it and then draw a queen, because I returned it, they are still independent of each other. I did not affect the outcome of the other one. Actually, sorry, it's dependent, okay, because I could have affected the outcome of the other one because I'm doing both sets of cards. Okay, what is the probability? Oh, that was, I apologize, that was independent because it didn't affect it. I'm going to change it 100 times. Okay, it didn't affect it, that's why it's independent. I was looking at this one. Okay, so what is the probability of drawing a queen, keeping it? Okay, those are going to be dependent on each other because it's going to affect my outcome. So drawing a queen, we already said was 4 of 52, but I kept my card. So that means instead of having 52 to pick from, I now have 51, which that's why it's making this one dependent now instead of independent. Okay, and then I have 4 kings. So when I multiply them, I get 4 over 663, and that means from my answer key that I had, this little guy would have been 1 over 169, simplified, because I was looking at my answer key wrong. So there's your 4 over 663. Okay, you have a bag of marbles that have 5 red, 6 blue, 10 green, 8 yellow. What is the probability of drawing a yellow? So first off, I have 8 to choose from, and if I add them all up, there are 29. I kept it, and then I drew another yellow marble, so I now dropped down to 28, and I had 8 to choose from. Since I'm picking another yellow one, I have 7, so they're going to be dependent on each other. So when I multiply them, I get 2 over 29.